In data science, we often work with Numpy arrays, which is related to the list in that it is mutable, so you can append and delete items from it, but it's got a couple of features that make it particularly suitable for dealing with large data sets. Namely, it allows for vector operations. So let's have a look at how to create a Numpy array and how to run through each of its items using a for loop. If we don't have our data imported from a file, we can also generate data. Typically in data science, we use random number generators to create data sets that have pre-specified features. So in order to access those functionalities from Numpy, we access numpy.random. Numpy.random is a library that gives us access to random number generators. And if from that library we import something called uniform, this is one example of a random number generator. I'll explain in a second what it does. So, and the way to use a function is like any other function that we have learned so far in Python. It's my array. That's what I call the outcome. My array is, we apply that function uniform. In round parentheses, we put in some arguments, and we need to look that up, or I just tell you here now. Uniform is a random number generator that gives you a number that are located within a pre-specified range. So if you want numbers that are all between 0 and 1, so nothing less than 0, nothing larger than 1, you can specify the lower bound and the upper bound, say 0, 1, and that's the range that you will get. In addition, you can specify as a third argument the number of numbers that you want. So if you want 5 random numbers drawn from the range 0 to 1, this is how you would do it. And if you then access my array, you can see that the outcome is first of all in square brackets, so like a list, but surrounded by that name array. And whenever you see array, you should remember this refers to Numpy array. Right, so here we have 5 numbers. They're all between 0 and 1 as specified, and we can deal with them further. If you want to check, we can also have 2 numbers or 22 numbers, whatever, 222 in that case. Let's see, that's 222 numbers, as many as you specify. So let's just stay with 5, which is a good number because we can see them all in one line. So let's try and now iterate through those numbers. So we use a for loop for number in, what is the array called? It's called my array, colon, new line indentation. And then whatever we want to do, we want to print that number. Well, you use print function and give it number as an argument, and then you can see them printed one after the other, starting from item at index 0 and ending with the last item in that array. Of course, having it in the for loop, you can do whatever you would like to do with it. So for number in my array, where's my array? Here's my array, and you indent, you can print not only the number, but you can also, I don't know, multiply it with 100. And then each of those numbers will be between 0, which is the smallest number possible, and 100 as the maximum limit. Let's look at a slightly more complicated array, a nested array in Numpy. So the way to do it is we use the same function that we used before. Where is it? So we create a new array, we can use the same name, and instead of telling it we want to see 5 numbers, we can also give it a tuple of numbers and specify that we want to have 10 rows and 2 columns in that array. So let's do that. Let's look at the output. The output of this is 10 rows, each row containing in square brackets a pair of numbers, first and the second number. So 10 rows, 2 columns. And this is the way how we're going to deal with data. So that's why n-dimensional arrays or nested arrays are an important concept. Let's try to index each of these members before we subject them to a for loop. So we have my array, and my array 0. What will it be? What do you guess? Well, if you know nested arrays, you can guess what the first item in that two-dimensional NumPy array will be. It's the first pair of numbers, and so on, the second, third, and so on. 10 pairs of numbers that we have collected in this array here. So the second number in that array, if you remember how we access things in a list, it was by using first the item and then we get a pair. So within that pair the first would be 0, so 0, 0, and indeed it works. With 2 pairs of square brackets it works. You can access that first number in the first pair like this. There's also another way, and it's the one that we use more frequently, within the parentheses to have the 2 indices separated by comma. So give it 0, 0, we get the same number. And this is the more frequently used way of accessing, of indexing NumPy arrays, is row, comma, column. So we can practice that in a for loop for pair in my array. If we loop through the items in that array, we can print the pair. But if we only want the first number, we can refer to it as pair 0, and that will now be accessing only the first number, or if you want the first column in what we had up here as a collection of 2 columns. And yeah, we have seen that you can subject it to any operation like multiplying with a number, dividing it something. Let's look at one more thing. It's as a function applied to those numbers, not just a mathematical operation. And let's look at how to calculate the mean of 2 numbers. Right? So let's just get our array back. We have an array that contains in every line and every row 2 numbers. How can we calculate the mean of it? Well, we can use a function called mean. And the way to get this function from NumPy, we need to import it. How do we import it? From NumPy, import mean. And then we have this function mean, and then we can use it within the for loop. So our for loop looks like 4 numbers is 2 numbers in my data. For the 2 numbers in my data, and remember it can be as many columns as you like. So we want to have the numbers, right? Every item in my array is a collection of 2 numbers. And so we want those numbers, but we want the mean of those numbers. So we apply the function mean to them. This will give us the mean of those numbers. And if we want that printed, we can, for example, see it on the screen if we put that as an argument to the print function. Now, executing this small piece of code, we can see that the mean function took each of those 2 numbers. Say, let's have it like this. So the first pair was 0.68 and 0.96, and the calculation of the mean returned 0.8243. This is the mean of the first pair. And so on until the last pair. Let's check that. 0.7, 0.9, and the mean is 0.8 something. And finally, just because that really doesn't look very nice, there is a way of showing that numbers with only a specified number of digits rather than all of the digits that Python can come up with. And we do that by importing another function, which is called around, short for array round. And if we import around, that helps us to round that number to as many digits as we want. So we repeat the previous code. I'll just copy and paste it here. Previous code was like this. That gives us the means. And if we want that rounded, we make that subject to the function around. And around needs a second argument, namely the number of digits that you want to see. So if I put 2 and add another round parenthesis to close each of those that I have opened, then we can execute that code and see the means of those pairs successively printed one per line.